Hey class! So today we will be doing something a little more exciting in Rhino.Inside. We will be creating from scratch a tower, a rotating parametric tower, and all of it will be generated in Rhino.Inside. We'll be generating the levels within Revit, the floor slabs, the structure, and quasi the mass. We'll work with the mass a little bit more later on in another assignment, but for today, we'll be creating those components. So we'll get started by opening our Revit template. So with this project, we are going to, as per usual, there we go. As per usual, we'll be working mainly out of our three-dimensional view. And because we'll be setting up our levels in Rhino.Inside, we can delete all but the level 1. We will delete that at some point once we get our level set up, but Revit does need at least one level in there. If you try and delete it, it won't let you. I'm hitting the delete button right now, and it is grayed out. So let's engage our Rhino.Inside to get that started. So we will essentially begin. It's a pretty simple geometry. It'll just be a couple of ellipses, and if anyone has looked at my Dynamo rotating tower, it'll be similar to that, where it's a series of ellipses rotating as you go up the tower. But it creates a pretty interesting, unique form, and it allows us to play around and create some more realistic elements, structural elements, and the like within it. So we'll start by just opening the grasshopper function of Rhino.Inside. And it is off my screen, so give me one moment. Okay, so let me screen, and my screen is freaking out at the moment. I'll just move this over here. There we go. Sorry about that. So we'll have all this out of the way. Okay, so let me turn my bifocals on and get started. So first we will want to generate the ellipses. So if we type in ellipse within Grasshopper, it's going to ask for a plane. It's going to ask for the first radius of the one side or one dimension of the ellipse, and then obviously the radius of the second. So the two radiuses, we can just do pretty easy. Number sliders 4, nothing too crazy. We'll just do a 20 by 40 ellipse. And then we'll want to essentially array these vertically up, then eventually rotate them independently. So to do that, we need to input a series of planes of which the different ellipses will generate from and be associated to. So to do that, we can do pretty simple XYZ construct points. So if we do XYZ or construct points like that guy, we can plug this in first. Now the two XY coordinates, we can just do 0, and we can just have that be at the XY origin. And then the Z coordinate is what we really want to focus on. And so obviously if you type in a number, it's just going to move it up in the Z direction a certain amount. But we want to array these up, and we want to have a good amount of control over them. So if I move these over in my workspace a little bit, what we're going to use is a series component. Series allows us, it asks for a starting point. So we'll keep that essentially right now. It's at 0, which we can keep it as. Then it's going to ask for a step. So that is essentially how many units each each series is going to be moving in. And then the count is how many times it moves. So if we think about this in levels, right? Since that's essentially what we're going to be generating our levels from and generating our floor slabs from, we want our levels to start at the 0 elevation. We want it to move up a certain amount of feet at every level. So every level is going to be a certain amount of feet. And then we want those to move up a certain amount of levels, right? So let's say I want 20 levels and each level is going to be 15 feet tall. So we'll do 15 for the step, and then we'll do 20 total levels for the count. And you'll see if you plug a panel in at the end, so you now have 20. Remember, the total is minus 1 of the total because you start at 0. And then it moves up by 15. So if we increase this, you can see that this is the amount that it increases by, and this is the amount of steps, or the amount of numeric values you will get from it within this series. So this is what we're going to be using to generate our levels, and this is what we will also be using to generate our rotating ellipses. So let's move this down to 15, and let's do, 20 is fine. So let's plug this into our Z coordinate, and let's kind of refresh that a little bit. There we go. All right, so obviously that is not very interesting. It's just an ellipse extruded. So now we will want to rotate these. So let's grab a rotate, just a basic rotate command, plug in our ellipse, and as we go through this, we're going to be hiding a lot of our previous components so they don't get they don't overlap and cause us a lot of headache trying to figure out what's what. First thing we're going to do now, if anybody is familiar with Grasshopper, you'll know that the angle in the majority of the components are set to radians by default. And if you want to input a degree, you'll want to right click on the angle and select degrees. There's also a component that does this for you, but Grasshopper integrated that nice little shortcut for everyone to use. Okay, so then so essentially we want each of these ellipses to rotate a certain amount. We want it to rotate a certain amount of degrees, and we can specify the total amount of degrees the entire thing turns, and then to what degree. So we will use a range component, all right, and then we will, so this is asking for a domain. So this is a range, well, it's kind of confusing. But the domain is essentially a numeric set of values of a minimum and a maximum value. It's a range of numbers, which is a little bit confusing, but you use this a lot when you're setting up different values. So I would get very comfortable in understanding what domains are and what certain components are asking of you when it asks for a domain. And a fancy tool is a construct domain component. So construct domain, we'll plug this guy in here, and then this is going to ask us. It's going to ask us for a start and an end, and basically what this range component is going to do is it's going to take this domain, which is also a numeric range, from, let's say 0 to 180. And then it's going to ask for a series of steps, and then it's going to divide that that range into the amount of steps that we've input, and then give us a nice evenly divided set of numbers between these two domain start and ends. And that's what we're going to use for our angle. So let's say we'll want our tower to start at 0 degrees. And let's just say for right now, we'll want it to end. Well, let's create a range or a numeric, a number slider, excuse me, from 0 to 360. So for those of you who don't know, I'll move my tab. If you hit a number and then dot dot and then the last number, this gives you a number slider between 0 and 360. And if you wanted to add a decimal point, all you have to do is type in a decimal point and it will generate a number slider from 0 to 360 with 2 decimal points. But of course we don't need decimal points for this, so we'll just do, we will do whole numbers. We'll plug this guy in, and we can actually lower this down to about 180 because it won't be as severe of a turn. And then this is going to ask for the amount of steps it wants within that range to divide to. So we currently have, let's see, we currently have 20 values. So we'll want to have 20 steps. We want a unique numerical value to plug in for each one of these ellipses. So we'll want to plug that in. Now, unfortunately, if we plug this in and then plug this into the angle, it actually gives us one more value than we need. So we have 20 ellipses and it has 21 values. So we need to actually take this number and subtract it by 1. So subtract by 1. I just hit -1 for anyone who missed that. This automatically puts a 1 into the B input. Plug that in, and now we have a nice even 20 values, 20 numeric values for 20 ellipses. And if you type in a panel just to visualize this range component a little bit further, you can see, right, that it starts at 0, it ends at 170, and then in between those it's evenly divided that list so that we get 20 values evenly divided between 0 and 170 to put into the angle. All right, and of course then we can manipulate this however we want. So we can untwist it, we can twist it a little bit more, but we will just do a nice gradual one. Wow, that's interesting that I got it right on 170 2 times in a row. So that is how we are rotating our tower. Now, what we can do is add a Revit element component, and we can add floors. So as you remember from the last tutorial, we can create floors from boundary curves along each of these ellipses. So we can use the ellipse as the boundary curve for the Revit floor family. So actually, you know what? Before I do that, I'm going to create levels. So let's do that. Let us create some levels. So let's go. Add level. So if you type in add level, and get here. So it's going to ask for an elevation type and a name. And we are going to, we don't need to worry about type. That's just the default, and that's perfectly fine for what we need. But we do need an elevation. So the nice thing about already having set up this series to create these ellipses is that we can literally just plug that guy in. And now we have a series of levels. Now, the problem with this, and we can now delete that level 1. And we can, fine, that's okay. So the problem with just leaving it like that is it does a automatic name generation. And as some of you have found out, this can be a pain in the ass. So what we can do with this component is actually create a naming convention and associate it with each level, and you can also add like unique names into it as well to have a much more control over the level names and not have to deal with renaming all of these levels and not having to rename it every time you move it, because I know if you had moved it, then it's going to regenerate the names and it's a pain. So what we're going to do is we are going to use a number, what is it called? A panel. So we'll want to start, we're going to create and we need to create a unique name. So we'll type, first we need to hit panel. And we need to disable software. All right, so we're going to type in a custom prefix to our levels. So we'll type in level and then a dash and then a space. So that will be our custom prefix. We want it to be different than just level because if it is level space and then a numeric value, it's going to treat it like it's adding to these already created levels, and it's not going to reset the level names. So just make sure that it's unique. It can be level dash, it can be level colon, it can be floor dash, whatever. Just make sure that it's a unique prefix to the numbers. And then we'll use a component called Concatenate. I'm going to spell it and you can figure it out for you. Concatenate. I'm sure there's it's pretty common and I'm just absolutely butchering it, but whatever. But this basically takes two pieces of information, two pieces of text, and merges it into one. So what we will do is we'll plug in level dash into fragment A, and then we're going to need the numeric values of each level for each level. So we'll want to obviously start with 1 and then move up from there. So we can use another series component, but this time we will just plug in the count. And so that because our step is defaulted to 1, so it'll be 0, 1, 2, 3, 4, 5. And we'll also want to, because we don't want this to start at 0, we will subtract 1, Control Shift, plug this in here, plug this in here, and then you can see what concatenate, the merging tool, I'll just call it that, does. Is it goes from 0 to 18, 19. We might not have to do that. I might have screwed up in I don't think we have to do that. All right, let's plug this in real quick. Yep. All right, so now if we plug that in, we can zoom in. We see we start at 0 and then go up to level 19. Now, if we want to start at level 1, not level 0, we can do a couple of things. We'll also, if we want to have our last level be the roof and not level 19, we can do that too. So we'll do both of those. So the first will be replacing 0 with 1. So we will just use the call index, grab the list, and then we can right click and set this to 0 since we just want the first one out of there. And so now we have a list starting with 1 instead of 0. Unfortunately, now we have a series, or we have a list that is 19 values instead of 20. So we'll have to actually add 1. So just do +1. Control Shift, plug that guy in, and plug this guy in. And then now we have 20 values starting at 1. I remember why I was subtracting. Now, of course, we have, name must be unique. What if I have to? Recompute. There we go. It's because it already had some of those values. So if you do run into that error, if you watch me, I just deleted all the levels and then went up to Solution, Recompute, or F5, and it'll regenerate everything. So now I remember why I had to subtract 1 in the example that I put together, and that is because if we want to add a roof level at the top, we need to reduce our series down by 1. So we'll actually probably just go back to to what we originally had. So if we disconnect, Control Shift, should be getting pretty good at that right now. Now we have 19 values again, and now what we will do is we're going to add one of these. We're going to add the text roof. So if you type in a panel, or if for a shortcut, if you hit backslash, and then hit roof, type in roof, it will create a panel with roof already in there. And then what we'll want to do is do a insert items component. This will take a list, so it'll take this list, and it will add an item, so roof, and then it needs to know what index it should add that item to. So we want it at the end, we want it to be the last level, the top level, and so we can just type in list length, grab this guy or girl and plug that into the indices, and now we have, if you type in panel, we have a list of values starting at level 1 and going down and ending with roof. So if you plug this into our level, we can see it's replaced that last level up there with the roof. Okay, so that's how we create levels. Now if we go in and we up the quantity from 20 up to, let's say, 42, now it will automatically generate 42 levels, ending with roof, starting with 1. And obviously if we go back down, it won't delete it, but if you delete as before and then hit recompute, it will regenerate those values, and no more typing in or retyping in numbers. It will automatically do it for you. All right, so that is how we generate levels. And now what we can do is do that floor. So add floor, plug our ellipses into the floor component, and then so for those of you using Revit 22, you won't have this problem, but for some reason RhinoInside in its infinite logic, infinite wisdom, that's the term I was looking for, in its infinite wisdom is only allowing multiple boundary curves in Revit 22 or above. However, if you know what you're doing and test some shit out, if you graphed the data, it will allow you to generate floors for all or for multiple boundary curves. If you're in Rover 22, you shouldn't have needed to do that. But if you're in anything before, just be aware. All right, so now we have floors. And let me see. Yeah, and the nice thing about this, and this is why I added it after we had created our levels, is it will actually associate each element with the closest level to it. And you'll see this too when we do our beams. It's relatively smart in that way. So, yeah. So you don't have to go in. Not all of these are going to be associated with the level 1. It's just going to associate with the closest level to it. So we don't have to worry about level. Obviously, you can worry about type if you want. If you want to create a certain type, and we might have to do that in your assignment. I haven't decided yet. But yeah, so that's how we create our floor slabs. We've created our rotating tower geometry for the most part, at least the ellipses and the floor slabs. So now what we'll do is we will create a form from that. So what we'll want to do is we'll create a loft where we use that geometry to then create a loft. And let's see, then what we will do is we're going to subdivide. So right now we're going to start creating our structure. And so what we want to do is we want to take this lofted surface and we're going to break it down into, we're going to panelize it essentially. So what we want to do is divide domain, use the divide domain component, and divide domain squared. Plug our loft into the domain. And then what we'll want to do is we will want to plug two inputs into, or two variables into the u and v. So for the v, and this might, it shouldn't, but it may differ. So just be aware. The v is going to be how many divisions we have in the long direction or the vertical direction, whereas the u is going to be in the horizontal. And so because you typically want your structure to intersect and be divisible by the amount of floors that you have, because obviously you want your floors to be connected to your structure, we'll have our u count or our horizontal divisions be the same number as our floors. So we will take the count, we'll plug that in here. Now, if you zoom in very closely, am I off base? No, it's perfect. Okay, I don't know what I was doing. I might have to, we'll see once we create it. I might be doing the same thing. Well, I don't know what just happened. Might be doing the same thing, but we'll want our u to be here. Okay. All right. So now that we've divided the domain, if we hide our loft, let's unpreview that guy. Okay. Just kidding. We haven't actually been able to see it. We need to use the Isotrim. Sorry, it's been a while since I used these, so be easy. So Isotrim, it's asking for domain, so that's what we've given it, and asking for a surface. All right, so here we go. So if you see, we did need to end up subtracting by 1. So -1, Control Shift, plug that guy in, and then plug that guy in. All right. So now if we hide one of these floors, you can see that the horizontal division of the isotrim is aligned with that floor. Before it was not. And we also have the vertical going up, and that is what is being controlled by this. So if we subtract this down, the divisions decrease and increase. Just so everyone's aware, just make sure that you have your vertical divisions be 10, just for consistency's sake. When I did some tests, it did not matter whether you had an even or odd number, but just so that we're all consistent, make sure that those are set to 10. All right, so now we have the divisions of the surface. We can then use a tool called Deconstruct Brep. There it is up at the top, Deconstruct Brep. What this does, so we've divided our surface into those panels, and it's giving us 190 panels. And what this does is it then deconstructs it into surface faces, so actual individual panels of the surface. Gives us the edges of all those panels, so all 4 edges of those panels, and it also gives us the vertices, so all 4 points of those panels on all 4 corners. So we're going to use the edges and the vertices to generate our structure from. All right, so what we'll do is we are going to, let's see. What will we do first? Oh, so what we want to do, so we're going to use columns and beams, right? So we want columns to be attributed to these vertical lines, and we want beams to be associated with the horizontal lines. So what we can do is isolate those by using a cull pattern. So the cull pattern we will use, and I'm going to unpreview this for a second because I want to know exactly what is being called. So I'm going to set a Boolean, and what I'm going to do, so this pattern, essentially you can type in a true or false pattern. Actually, we only need 2, but since there's 4, you could do true, true, false, false. You could do true, true, false, true, true, false, and then it'll just repeat that pattern. Whatever pattern you plug in, it'll just repeat it. So it looks like it's only selecting the verticals here. So that pattern again was true, false. Now if we copy and paste that cull pattern and we change it to false, true, if you zoom in, you can see we are now selecting all of the horizontals. So now we have isolated the verticals and the horizontals to then attribute either our beams or our columns to. All right. And so one thing that we need to be cognizant of is, even though these between the 2 points they look relatively straight, these are actually curves. So all these edges are technically curved, and so Revit columns and beams work off of perfectly straight lines, or axes is what they'll call it. So if we plug in a add beam component, and then also, so do that here, and then add column. It says curve because technically a line is a curve in Grasshopper, but it is technically going to ask for a straight line. If we try and plug this in right now, it's going to give us an error because we need to have it convert from a actual physical curve to a line. And so what we can do is use a rebuild curve command. rebuild curve, plug this guy in. And before we do that, we're going to flatten this list coming out of here. So what we're going to change are its degrees and counts just to 1. So that essentially flattens out all of our curves. All right, and one thing we have to be cognizant of is because, if we go back here, because our deconstruct brep, we're deconstructing each of these panels. That means that each panel has 4 curves associated with it, and that means that there are 2 unique curves per instance. So like this panel had an edge here, and this panel had an edge here, and so now there are 2 curves at the exact same point. So if we go in, and I don't know if you can see, but that's our rebuilt curve. So you can see it is very subtle, especially if you have a taller, more gradual rotation. It's going to be very subtle, but it is still curved, and you'll see it a little bit more when we do the horizontal curves. But what we can do is plug in a component called remove duplicates. Remove duplicate lines. Oh, and I should have mentioned before, all of these, so remove duplicate lines, and I believe concatenate, whatever. Oh no, that's in sets. Okay, perfect. So this remove duplicate lines is actually in Kangaroo. All right, so please download Kangaroo. I'll send out an email, but to get this component, you're going to need to download Kangaroo. And honestly, Kangaroo is really good. It's almost as good as Lunchbox, although Lunchbox is a little bit more handy. But Kangaroo is more physics-based, but it does have some really great utility tools like this one. So if we plug in our curve into the lines, then you can see it's taken 380 curves and removed all the duplicate lines and given us a list of 190. So now what we can do is plug that into our column. Now, before you do that, just going to say 190 unique lines and having columns be generated from all of that. It's going to take a while. So I personally, if you have a slower computer, I would probably reduce the amount of floors you have, reduce the height, maybe reduce the, just reduce the height. The other thing you can do is you can go up to here to solution, hit disable solver, and then follow along. And then once we have everything plugged in, then you can hit you can disable the disable solver and have it generate and just be ready for it to spin for a while. So before we plug those curves in, let's pick a column. So we'll want the category component, right click, and then there are columns, and you can select columns, but we're gonna go down and pick structural columns because they have the most options. So make sure you double click, select that, and then select our element type picker, just like we did the last couple classes. Plug that guy in. Oh, and that's the one thing that sucks about disable solver is it won't actually solve anything. So if you plug something in, it won't generate whatever optionality it has until you run it. And so we can see we only have the 2 W-shaped columns. So what I'm going to do is I'm going to go into insert over in the Revit. I'm going to load family. I'm going to load a nice round column. And I will upload these. Sorry, I have to go to structural. I'll upload these for you guys so that you have the same exact one as I do. So I'm just going to do the round hollow structural section. And then I'm just going to scroll down and select let's do a 12. And then for my other one, I'm going to do an 8. Let's do 8.65. That's fine. So I'm going to load both of those in. All right, so now go back, hit recompute. Now we have, of course it's going to, okay, there we go. And now we have the 2. So we're going to do a secondary set of columns. So we'll pick the larger of the 2 right now, plug that into our type, and then plug our unique lines into the curve. And then, of course, now it's going to spin. All right, and now we have columns at each one of those curves. And just like our levels, they are associated with the closest level. So it's super smart when it comes to this. All right, so now because we already have this, we can copy, paste this down, move this guy down a little bit, plug our call pattern for the horizontals in here, and now again we'll want to flatten this list. So let me see what happens when we don't flatten. I don't think it should do anything. Right click on our categories, and so for beams, it's actually the terminology that Revit uses for its category is structural framing. So make sure you double click that. And then once again, we'll go to load family. And then again, I'll give this all to you guys. You don't have to find it. Actually, let's do around 2, but let's do like a 12 by 6. That's fine. Oh, let's do 12 by 4. That's nice. All right. Again, recompute so the new one loads in. Plug that into our type. And then let's see if this list will work. All right, and it's finished, and it looks like, that's why we flattened it. All right, let me flatten this. It's because, I remember now. So we flattened this guy because, we'll flatten back here. Yeah, so the reason why we flatten this is because this component will not understand that the 2 curves are the same because they're technically in different lists. So we need to flatten it so that this will then call out the unique curves. So we have 380 unique curves here, and now 200. All right, and then this is just giving us an error, beam slightly off axis. I've found that if you zoom in here and hit document, for some reason that will get rid of the errors. Of course, it's not super important because sometimes the beams are just going to be off by a little bit. But that is how to create our initial beam and columns. Now, if you zoom in, you can see that our column is actually intersecting our floor slab. Now, we don't want that to happen. Obviously, these are going to be intersecting, and we could fix that, I guess, but we won't do that today. What we will do is essentially offset the generating surface that is creating these columns and beams. The dimension of the using the dimensional qualities of the structure, essentially creating a smart script that will always offset at least the columns off of the floor slabs by its own dimension, so that they're not intersecting the slab itself. So what we will use to do that is what is called inspect element. So if we hit inspect element, so we want to use the columns. So if we plug in the column in here, and then we double click, right click, show all parameters. This is going to show all of the parameters you can have for whatever element you've plugged in here. And so we want this guy, which is the outside diameter of the round column, and that is currently 1 foot and 3/4 of an inch. So what we'll do is we'll take this and use it to offset. So we'll go all the way back to our ellipses, or rotated ellipses, excuse me, and we'll use an offset curve component, plug our geometry in, go back here, grab our outside dimension parameter, plug that in. All right, make sure that actually we'll do a XY plane, excuse me. XY plane. Let me just make sure that's right. Oh, XY. Ooh. And we'll want that XY plane to be at every one of these. Yep. All right. Plane curve, and then. Yep, and now we have curves offset from the original ellipses that are generating our floors by the full dimension of the column. Now, of course, that's the full dimension. Technically, we only need half, so we could use a divide tool, divide by 2. And Control Shift, take this distance, plug it into A. And now we have it half the dimension. And then what we can do is literally just plug these curves in to the loft instead of the original. And then we will need to flatten this list. And then, of course, they're going to regenerate all of those columns and beams, so it's going to take a second. All right, and now you have it offset from the floor by half of the diameter or the radius of the column. All right. So now, of course, in reality, because we have this ellipse and it's a tighter radius on the ends than it is the long sides, we could manipulate the script so that it has tighter verticals and tighter divisions on the ends rather than the long sides. But for right now, we will just stick with the basics since we're already, I think, at 50 minutes. And what we're going to do is, as it stands currently, even though this is pretty cool and unique form and structure, right now, if we were to build this, it would collapse on itself because the horizontal and vertical beams and columns that are currently making up its structure is not stable enough to do it. You'd have to put in some really thick moment connections at each of these intersections each of these nodes to actually make this stand up. And so what we need to do is add in some diagonal bracing into here. So we want to have a member, a column or beam, basically go backwards and create more of a triangulated structure. So now you could do similar to what we had done before with the divide surface and creating those square panelized surface with a triangulated one. But there's a simpler, well, at least with what we have currently created, there's a simpler option that we can do with using the vertices of the deconstructed BREP. So what we can do is take these vertices and we can isolate essentially this point. If we're looking at this panel, we can isolate this point and we can isolate this point, and then just use a simple 2-point line to connect the two, and then use those to generate those columns. So to do that, we'll do a list item. Plug a vertices into the list. And then let's type in 3 here. Should be 0, but let's see. All right, so now we have, let's see, well, it's going to be really hard to see, so let's just test it out by creating a line, 2-point line. Plug this to the start, this to the end. Oops. So we need our index is going to be either 0, 1, 2, 3. If we look at a panel, and the reason why we don't flatten these is because currently they are broken up into sublists. Each sublist consists of one of these panels. So each panel has 4 points. So let's just say this is the first panel. This panel has 4 points associated at point 0, point 1, point 2, and point 3. It might be starting at different points. I'm not 100% sure. But each of those is represented here. And then what we do with this index is if we specify, let's say, 3, then that's going to isolate the third number in that list. And we can put it to 0, to 1, 2, or 3. So what we're going to do is we're going to type in 0, we're going to type in 0.3. So we just created a number slider from 0 to 3. And then we're going to do another one, 0.3. And let's do, so it should either be 0 to 2 or 1 to 3. So let's do 0 to 2. All right, so that is the opposite of what we need. So let's do 1 and 3. Hey, look at that. All right. So now we have our lines, and they're already straight because they're only connecting 2 points. So we can use this to generate a new set of columns. So let's not copy and paste this. Let's copy and paste this. Bring this down here. Do add column. All right. Type in or plug in the type. And let's put this down to that lower or the smaller section column. And then let's plug in these. Oh, I forgot to do one thing. I forgot to flatten and remove duplicate lines. So this is actually going to create duplicate columns on a couple. So let's delete this for right now, so we can delete all of the columns. It's going to pop up here. Let's say delete all. All right, let's go back here. Let's do that again. Add column. Plug this in for the type, and then before we do that, we're going to flatten these lines, and then remove duplicate lines. And now plug it into the curve. All right, and now we have triangulated structure for our rotating tower. And I think that is all for today. All right, so rotating tower, rotating structure. What I think I'm gonna have you do is use a different profile to create your rotating tower. I'm gonna play around and test it out and make sure that that's not gonna cause any issues for you guys. But obviously I'll have more information during class. And you know, it goes without saying, but as most of you probably should know, this takes a lot of computing power to apply all of these Revit elements to the geometry that we create within the Grasshopper environment. So if you want to manipulate, if you don't like the amount of curve you have, or you want to increase the amount of levels, decrease, if you want to manipulate it at all, I would highly recommend, disabling, or if you hold Control Space and then hit, if you have selected them all, Control Space and then hit disable, then you can go in and you can actually, and if you go in here, let's disable the floors as well. What you can do is you can just highlight everything and just temporarily hide it. And then you can go in and manipulate whatever you need, and it will be much, much quicker. So you can increase or decrease the amount of the height of your levels, the amount of levels, the amount of rotation, the amount of vertical divisions that you want, or if you want to increase or decrease the amount of horizontal divisions. Perfectly up to you. Just be cognizant of the amount of, essentially be cognizant in the amount of elements that you're going to have, which ultimately result in the amount of calculations and computing power your system is going to need to do to be able to solve all of those computational problems. So right now it's just stretched it out. So, and the other thing too, obviously, disable solver. That's the easiest way to do that. And then if you have disable solver on, you can keep it on. Let's say I want to increase the height by 20, increase the amount of floors by 30. Let's increase the radius to 52, increase the amount of rotations, and let's increase the amount of divisions. Let's go 16. All right. Now you could uncheck disable solver, or you can just hit recompute, and it will recompute everything. It'll kind of act like a stream filter where you press the button and it releases everything, solves everything once, and then goes back to disabled. So play around, and I will have the requirements and deliverables for your assignment listed on Canvas.